Statistical Mechanics Part 1. Okay. We shall look into this probability density function. And focus on what the different probabilities is with respect to EA. So it should be probably some. We have both particle A and particle B. So that will mean that we would probably integrate over, and the energy depends on the momentum of particle A and the momentum of particle B. And fortunately, we have a relativistic case. So that will mean that we are multiplying with the speed of light. So that means we have 2 dimensions. So we essentially need to loop over, because you can think of an integral as a sum, and the sum is looping over, and inside is obviously a function that takes different values of PA and PB. So different values of PA and PB will be inserted. So if you imagine a sum, that will mean that for every possible PA and PB we have, smush it in and sum up every contribution from each value. But when we have an integral, we are summing over every single point between our limits, and you know that's infinitesimal. I think I said it right. Sergeant Blaine is not coming before the evenings for gaming. Now this is Brother Blaine, and this is Physicist Blaine. Good to see you there, Vintage Tech. We need tech. We have a fellow Marine here. You better get your interest in physics, brother. We also need to fight with the pen, brother. Because what is the mystery and the functional and information of all technology and all our weapons? Well, at the bottom of it is technology. Imagine a weapon. A weapon utilizes thermodynamics or statistical mechanics 100%. That's why we gotta study, brother. So now we're starting off by imagining particles. And this is the momentum. So we can obviously move in any direction it wants. At least we are just considering a one-dimensional case. Oh yeah, brother. You need to get that recoil low and steady. You should Google Vector. In real life, it has 0 recoil. There was an amazing physics and engineering into that piece of art. And yes, the particle can move, can have momentum negatively and positively. So it will unfortunately be from -infinity to infinity. And then I think we have the probability of each momentum. Gotta be careful with these p's. These p's can be quite confusing when it's momentum and probability. So, then comes the question. I think I remember there will be some... Isn't it called Delta Chronicle? And then we have to consider our energy constraint. Because this is essentially a constraint that the only possible values for our energy is by combining EA. The constraint is that EA must, when added together with EB, sum up to the total energy E. So this is a constant. But EA and EB can change to whatever they want to, as long as they shift together, you know? Yeah! The theoretical physics, that's the real beauty. We can leave numericals to the programs. We first find the real answers with the theory, and if we need some help to solve the theory, we can just numerically solve it. But Einstein, he did physics only with pen and paper, at least in the 51st years of his life. We see what he managed with only the pen and paper. So we focus on the computer. It's only our tool, the tool we use to solve when the theoretical physics gets a bit out of hand with big numbers. Then we use the computer to help us. So I think we could say that E minus EA plus EB. That is actually EA plus EB. That's easier to see. But when you have the minus, this goes into both terms. And this is a cheat trick because any other energy, let's say if EA, if our total energy is 1 or 10 and EA is 5 and EB is 6. That will not be counted into our integral, because then you get EA plus EB, that's 11, and that is not equal to 10, which is our E. So EA plus EB must equal to E, and this delta Kronecker function inside the integral, it does such that every energy outside that constraint gives us 0. So when you integrate over this, this thing would just become equal to 1. Thank you, brother. Maybe soon it will be Professor Blaine. Daytime professor, and then entering the dark night mode at night, fighting the enemies with steel as Sergeant Blaine. Semper Fi. Yes, so this becomes 1, because all the other contributions, the only possible thing is that EA plus eBay is E. So inside here you essentially get E of 0. No, delta of 0. So I think I might be a little bit quick here. Think we have to do some substitution. Yeah, and we need this probability to be expressed probably in E. Yeah. Because it's often a trick, or yeah, I think you can say a trick. Hell yeah, brother! Bringing the podcast voice. Hell yeah, brother! Yeah, you have to stay hard. I was supposed to maybe write title in the title that this was a Goggins style studying, because when the cameras are off, the lights are off, and all I have is my head and these notes, well, there's hell inside the head. Let me tell you that. Doing this several hours, or up to 10 hours a day, then you can see the devil himself. We must crush him. Fight the demon inside your head, brother. So I think the next step will be to find the probability. What should we call probability? Okay, this should be the probability PA PB. I think this is a trick. Again, integrate over the whole space, or the whole all the possible values that we can have for the momentum, and if you do that, that should be equal to 1, because this P of PA PB is a probability density function. So that means that if I wonder what the probability of PA being 1 or PB being 5, I would like put P of 1.5, and then you would get a number, because that's it's a function, probability function. So I would get a number that would be between the 0 and 1. Many are 0, but there's quite a few that's non-zero as well. So let's say the probability of PA being 1 and PB being 5, or let's stick to the other example I gave earlier, that okay, that wouldn't matter. Yeah, but that would anyways give me one value for the probability of getting those two momentas. So that means that this P, PA, PB, I think you could say that it might look something like this. In other case I have had it looked like this, where you had the probability here, and then you had different values of PA, PB. Should really be 2D, 3D basically. And so that will mean, okay, if I choose this value of PA and the corresponding value of PB, I would get this probability. That was like maybe 25%. Maybe that was 25%. So every point here has a probability, and the probability must always add up to 1. So if that point has 25%, maybe this point also has 25% over here. Maybe this is like 1%. This is maybe 1%. But if you add every single point up, it must add up to 1. And adding all those is a sum. And what happens if you can choose any point on the what's talllinje in English? Every point in the I guess what in the name of the universe is talllinje? And the number line, of course. Yeah, so when you can choose any point in the number line, you can basically choose infinite amount of points. So then you would need the integral. And PA, you see that also we have that E equals PA squared over 2m. That's kinetic energy. I think I forgot. Yeah, I forgot. Is it just c squared? Yeah, if you just take this and square it, should be c squared as well. To get the kinetic energies. No, they didn't. maybe they don't care that much about the mass, or that the mass is included somewhere. Somewhere I don't know. Universe works in peculiar ways. That's no surprise. So you can think that the momentum of this one particle could be... Yeah, okay, so that's probably... could say it could be a limit. It could be up to close to speed of light. That would mean that the other particle would have basically zero momentum. So we see that all the momentum can be in one of the particles, and then there should be corresponding approximately zero in the other. It's like no, what's the name of that? It's like a, you know, a weight that if you put more on the other side, that side goes down, and then you get, then you have to take less on the other side, so that side goes up. An old-fashioned weight. So, okay, I think this is what we need to solve first, because or else we can't solve it, I think. And after we have put in that this should be expressed probably in energies, and or not necessarily, this could be expressed in, yeah, that's probably more natural, that this should be expressed in momentums. So that we could just put in the momentums, and we should be able to do the same here. So we need to figure out what this is. And maybe that is... we're just going to... oh, it's an ugly integral. Nature is not always pretty, so that doesn't mind. Okay. The probability of each momentum. How can we express that? How can we express that? Any suggestions? So, yeah, this probability probably also will be, we could probably use the delta trick here as well. What would that be? Still need this, so that's a start. Okay. Should be like this. Is it just the momentums? Yeah, it actually is. It is real math here, brother. Well, it's going at least. It's going. It seems like it's going forward. Hope. Because we actually can get the energy. We can use the same trick here. Which maybe I was wrong here. So, so maybe this one should be here. Inside that. It's going, yeah. I just found out that we were going somewhere backwards around here. But now we went one step forward. We can just say EA. This and some normalization constants. That's very normal. I think normalization constant is sort of cheating. Like, yes, the probability has to be 1 when you integrate over the whole area of these possible values. The probabilities. That's okay. But shouldn't it fix itself? Shouldn't it be 1 by itself? I think it's kind of cheating by multiplying by a to get it to become 1. Maybe that's a mystery out in the universe. Who knows? Okay, yeah, at least we have this to work with. And I still think the limits should be the same. Yes. So this one is probably more easy because this not positive. A, of course, outside. That's easy. It's easy because we just accept it. We accept that it's the constant. Cheating. We can just take this. Yep. Then fill in the task. Gave us this momentous. Hopefully they are from nature. This should be fun. Oops. Edits. Are you also a physicist? Or trying to be? I think it's a wonderful path. But it's one hell of a path. True statistical. A lot of statistical mechanics. Should be a nice name of quantum mechanics as well. Because it's more like hysterical statistical mechanics. Now we can just plug in. If we take, I like to think of it as a partial integral, because you first integral with regards to PA, and you forget all the PVs. But god damn, doesn't that mean that it's just 1? How can this be? If I plug in PA, that's just PA. E over C. Yeah, if I plug in PA and PB, this is not the delta is not 0. I guess maybe you can use the trick that it's symmetrical. I think it's then you would get, you have a 2, 2, 4. I think that you would just get 4a from 0 to infinity, and 0 to infinity. I think the trick here is to think, what can I do to make it such that if I plug in PA and PB, this becomes 0. Can I just divide by C? Is it allowed just to divide by C? But how can I divide by C? When it's respect to inside, when we're considering inside the delta and outside. Check this a bit out. Son of a gun. Ambins went out of hand. There it is. So, maybe if you just, okay, we know that E, yeah, you know that E minus P A C minus P B C equals 0, so You just divide by C. EC. Swoop it away. Swoop it away like it's jiggling atoms. The atoms are jiggling. So I guess this is still true. Follows the constraint. Because PA and PB would have to be such a way that E over, when subtracted to E over C, it would give okay. So it's not like you are inside this equation that it equals 1 and like actually dividing by C or something, I think. Because that would make it 1 over C. Maybe you're just pulling out the C from the delta. Maybe it actually is. It's some delta rule. Yeah. So that's some delta rule I forgot. You do this, and can we say that? Let us say that this is our C. I'm sorry for I don't have my wiper, or what I should call it. So if you pull out C, swoop them away because the particles are jiggling. Just kidding. This, and then this is all delta. And then we can just, because it's a constant, it follows like some scaling rule. Not too familiar with that one. Okay, it seems like it then would be the scaling rule is that you have the C there, constant, and it actually becomes the absolute value of this, and C is obviously positive because it's the speed of light. That's a weird one. We need to study that. It's delta? Why isn't it just normal C? Why isn't it just C times the delta? Physics and all this talk of universe is making my feet a little bit cold. And that means I have to do some thermodynamics, and also statistical mechanics, a statistical mechanical stunt or solution. And that is to put on some wool socks. Because you know the wool socks, they will, for the first part, the material, I think there should be some, it's not just insulating or isolating, but I think there are also some thermodynamical properties of the wool that absorbs or something. I don't think it's just because insulating is often just by air, because air is a very good insulator. But maybe that's the only part in the wool that's helping our feet not stay cold, because the wool is so fluffy. The wool is so fluffy that it makes more air. You can see the wool fibers makes more distance, or the air layers between you and the environment that is colder. And it seems like the air doesn't escape. Enough about wool socks and thermodynamics. I'll be back. Thank you for the follow, vertebrals. Welcome to the Marine Corps. I think there should be some notification. This OBS is one interesting and giving a lot of technical problems, but still very, very good. Stream was supposed to be a 3-hour stream of statistical mechanics, becoming even more statistical with time. But due to technical difficulties, there was a lot of stuff that had to be fixed. Because there was a problem, and there was a problem with the problem, and then there was a problem with that problem that had a problem. And yes, and time just keeps going, and times keeps going now as well. And I should be trying to solve this exercise. But I am really curious. Curiosity is probably the most important thing when dealing with academics, because it can be boring as hell if you're not curious. And now, luckily for me, I got struck by curiosity of why delta, see, fortunately there's a rule, delta C times X is equal to 1 over C times delta X. And that seems counterintuitive, but nature does not follow our human, petty human logic that we have experienced a lot of times. Just imagine the Stern-Gerlach experiment. That's my go-to argument for why human logic is a big pile integrated from minus infinity to infinity, integrated up to a big pile of shit. Bullshit. Our logic cannot be the way the universe works, because the top tier scientists and physicists of the time, I guess in the 1920s, they were doing the Stein-Gerlach experiment, and they calculated with very precision that the electron should be going at certain places, think it was in the middle. And it was time to do the experiment. They applied the magnetic field. I think they didn't think that the magnetic field would affect the path of the electron. Or maybe it already was applied. They needed it. Anyways, they did the experiment, and the electrons went down and up. Why did electrons go down and up when all the physicists thought the electrons were going to go in the middle? So that, by that I conclude that human knowledge is petty compared to the knowledge and nature of Mother Nature. So, that means that according to Mother Nature, 1 over c times delta of x is obviously delta of c times x. And maybe I'm so lucky to see or can grasp why, or get satisfied and I can get a satisfactory explanation of why it is like that. Even though if you keep asking why and why and why, you will get to we don't know. Heisenberg, oh yeah, he is one of the good ones. This is working. I think I'm not. It might be that the uncertainty principle is connected here, but I think that is not so easy to see. I think the goal with this task I think maybe the goal of this task is actually just to find that probability density function of EA. With that I mean there could be some like more pedagogical reason behind it, but it seems like this is just to get our hands nitty-gritty into the calculations. The math is not that difficult. I don't talk in regards to myself, but if someone else, a mathematician maybe would see it, would probably say that, oh, this is easy. But what is probably supposed to be the most challenging part is to know what mechanics, what math we have to use. Because it's like you have to open a black hole and drag this equation out. Because it's not that intuitive the first time you do it. Well, I think actually these tasks, this is right before, I think, we start with quantum statistical mechanics. So I think we're still just classical actually. But it's maybe this task is hinting over maybe still classical actually, even though we're having relativistic particles. Yeah, this is just the particle's momenta on a curve. You're goddamn right. first I'm just gonna try to figure out why that delta is that way. So it's not, you're right, it's not the wave function. It's just a probability function. And I got corrected one time, it's probability density function. But this thing now is boggling my mind. Because I understand that you probably just can't pull out a constant out of this delta, because this delta is a very peculiar function. Yes. Well, statistical mechanics, it's like the nitty-gritty version of thermodynamics. There was French physicists who I think developed it because they wanted to understand the mechanics behind the steam engine. And my professor said that statistical mechanics is a whole bunch of integrals. And I've done some tasks on it now. And yes, it's a whole bunch of integrals. Oh, I think actually, the constant actually maybe comes from you have to change variables. So maybe it's just this. Dx equals C. Yeah, because that means that du over C equals dx. So that's how you get the constant out. And here it's like you could probably just call all of this u, but I don't see a change. Don't see a change in variable here. They are basically the same, just constant difference. Oh shit, camera. Oops. Idiot. Camera has some 30 minutes auto shut off when it's in live. Unfortunately. So we will see if everything crashes if I try to turn it on. There are things in motion. Yes, double integrals. Last task had the triple integral. But luckily I think you can just think about it in a way that it's partial integrals, the same way that it's partial derivative. Then you can just throw all the other variables outside of the integral and only integrate or differentiate with the ones that have the one variable. So the same you can do for the double integral. Oh, I'll be damned. It worked. Yes, so it's a bit weird. Because shouldn't you call these two variables something else if you do a variable change in here? Or rather up here? Maybe it's just that when you get this, you can just call yeah, so that's a little bit weird. Or because it can't be that you have DPAC. Cannot be right. That is outrageous. Maybe this is just something we have to remember. Sometimes you get stuck and try to understand everything. Why is that? Why is that? Why do you multiply by the Jacobian? Why do we do that actually? Why is it like that? It's just 2 dimensions. Why do you multiply by it? And like this, why you just you take 1 out, but how do you change the dependence and etc. But then it's not time for anything. But I think I'm reading some here. Okay, if you have f of x times delta alpha x dx, you do a variable change. That's what we did. Y equals alpha x. But then you get dy. Where do you pull that? Just try to check one last thing about it. Let's say that it's fine. Then I wonder, when you put in, doesn't it just this make it this becomes just 1? But okay, maybe when you do the variable change in that, you get c, so you'll get maybe squared here. It's a bit weird. But I guess if you do this 2 times, you'll get 1 over c, and then 1 over c. But shouldn't you like put in the u again? Or maybe you just call it dPA again, like a new dPA. dPA 1 equals It's weird. I don't think it's just... I don't think you can just take it to that. Change the variable 1 time, and then we have 2 integrals left. Let's stay with that. But it is a bit weird. Because how can you... Because to get the c outside you have to do a variable change, but we basically didn't. We just pulled the c out. So how do you get back to dPA? But how would this look in our case then? If we have delta can you call the whole thing a variable? That can't be possible. Can this be? Let's see. So we have the delta of, for instance, c times x. It's 1 over c delta x. Yeah, the integral on this is just this is 1, and we put in PA and PB. Okay, maybe you can think like this. So if you put a constant inside, if it's just delta and c times x, and you, because you know that this gets a little messy, but just focus on where my pen is and blur out everything else. You should be good. So you know that this of f of x, delta x, and like if you watch f of x here, it's like f of pa point, comma pb, and yeah, our like function like this is basically just one. there's nothing, but you can still say it's there, you know, math. Dx, and this is just zero variable else from where x is 0, so that means that f of 0. So maybe the thing is to think that you have, if you were to slap a c in there, so you instead have c times x. That would oh, that's still 0. I mean, you would need to change variables, yes. But so you would change this to u, for instance, and then we would get like this, as we said, 1 over c. So you pull 1 over c outside, and you're stuck with just f of u times delta u du. That is still just this. So all you end up is 1 over c. Maybe that's just the way you should think about it. We have a bot trying to enter our calculations of the universe. Goodbye. You know that person? That was a bot. And the bots, they're outside our delta. So they contribute 0 in the integral. I'm sorry. So, okay, okay. So, I always get in trouble when doing deltas, because they are so messy. Follow the strict rules of the deltas, so you can just don't actually need to do the variable change. Basically, just pull the constant out. So when you pull the constant out, what is the next step? What is the next step? we have this integral, and when we put in... Yes, yes, yes. Ooh, it should be you. Ooh. Aha! Oh. Maybe not. The statistical mechanics is getting the better of me. I can feel the statistical emperor approaching. Mother Nature, help me. Summon forces from me, Mother Nature, so I can solve the integral of trying to explain your particles. I'm just trying to explain your jiggling particles. So... Is the microphone popping? Popping very much? Or is it okay? I'm just gonna listen. Okay, maybe. Maybe the nature sound is a little big. But if we solve one integral, what do we get? If we take... Don't you just get one? If you... Okay. You do the integral one time. Let's say you take dB first. Integrate with respect to b first. Then you would end up... That should just be 1? Or no? It is... yeah, it's... yeah, it's 1 because this function of b, if you can say so, it's just 1. But this is not 1 yet. This is still should be like this. Yeah, shouldn't it just be the same? You just put in... Maybe not absolute value. That sounds fool. That looks foolish. And you get like this. But maybe the limits are different. Now, what do we do? This is making me curious. Curious and furious, to be quite frank. Because don't you just put in? You don't understand why this is not equal. Isn't it just like this? But why isn't it true? You fool! So we see, if we focus on the integral from, that's just the partial integral, like I like to call it, of dPb, and the only thing that PB can be PB we see that PB must be equal to, for the delta to be 0, the PB must be PA minus E over C. That makes sure that the delta is 0. PB so PB can be, that can be basically anything, right? Because E can be whatever. But is it right to have limits to infinity? Did I do it wrong? Oh shit, I did it wrong. It's minus BI plus E or C. Sorry. Can't you just like say that the integral over PB is just 1? And that it doesn't change anything? No, it must still satisfy this PA and plus E over C. PB. So what to do now? Whoa. What's the matter, your camera? Oh my god! Isn't the universe peculiar in any time? In any ways? The problem now has become that the camera doesn't focus. Oh my god. This is how you do math. This is like the Heisenberg uncertainty principle. Because if you have too sharp precision, the momentum gets smeared out. A little magic hand had to come. So, the delta says that PB must be E over Z minus PA. That's okay. Whoa, hold on a minute. Does that mean that PB has to be positive? But I guess that's okay, maybe that's like relative. So it could be the other case also for PA. Because maybe it's like, yeah, it doesn't matter what's positive. If PA is positive or PB is positive. It's just the opposite. So positive has no, it's just relative. So, but here we see that PB, because E, that has to be positive, total energy. At least that's how we defined it. So PB is this minus PA. That means that PB must be greater than 0. Cannot be negative. So maybe this is like but that means that over C, it's also can be equal. It can be 0. PA can be 0. That's okay. Then the PB just has all the energy. PB can be PA must be at least less than that or equal. can be equal as well. PA is equal, then this is 0, PB is 0. So that the two like boundary conditions. PA, but PA must be bigger than 0. But doesn't that mean that PA and PB is both positive? I thought some of them could be negative. Oh, we basically, yeah, we didn't mind. We got rid of the negatives, anyways. So if we start with PB, that means that PA has the limit up to E. But does that mean that PB can be whatever? Does it still keep the infinity limit? So if PB is 1,000 millions, obviously, no, this is basically the same. Obviously, this has to be true or equal. It has to be either this so. Sorry for the sonic booms. Yes, PB has to be. If PB is 1,000 millions, then E over C could be 1,000 millions and 1. We're not cheating anyone now. And that means yeah, we should. I must check that also, because it couldn't be wrong to say that limit of PB and PA was also E over C. It's not actually infinity, right? Well, maybe it is. God damn it. Because but can't be bigger than E over C. don't think it's possible. Could really, if PB was anything from 0 to infinity, is it possible? If we look at I mean, if you just have to confusing. Because if you look at this equation, couldn't I just have PA 1000 billion billions? No, because they're both positive. I think this is what's screwing with me, that if you have that PB or PA could be minus, could be negative, that would mean that if PA was 1 billion billion billions, then that's okay. If PB is positive or negative 1 billion 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 millions plus 1 or something, if the total energy was 1, right? That opens up all possibilities. But I feel like we are restricting ourselves when we say they're just positive. Because then, obviously, then PA can't be whatever it wants. Because then but then you should. Yeah, we did. Okay. No, then we should. Then it shouldn't be allowed to say that the limits for PB was 0 to infinity. Yes, we did. Or PA. When we changed this, when we changed the integral to from 0 to infinity. minus into in. Is allowed. Because then yes, I suspect we have a Mr. Fisher. What took you so long, Fisher? It might be a trap, or it might not be a trap. But maybe it's a trap that it's not a trap. Who knows? Not even nature knows. Because as far as we know, nature is probabilistic. According to improve, well, I found that it improves maybe improves on focus, because it's darn oh, what's the word? It's darn humiliating if I'm stuck at the same task, or at least the same line, for hours straight. I didn't need to check, Mr. Fisher. I didn't need to check. That is an equation or wave function that is actually not probabilistic. It's a classical wave function, my friend. I found that Mrs. S actually might be wrong. Because Mrs. S she is saying that, oh, or maybe not. Yes, she is wrong. Yep, because you cannot have. This is not Mambo, my friend. Task 19.1. It is not possible in the universe that you can have your limits from 0 to infinity for the momentum PA and the momentum PB, because you have to follow the equation, or the constraint, sorry. E over C minus PA minus PB equals 0. And thus is nicht 0 if PA is whatever it wants to be and above E over C. Because obviously E over C is not E over C is not infinity, right? Nature doesn't play such games with me, right? And I totally get it, that it's allowed to say that the integral goes from minus infinity to infinity. Because for both PA and PB, because you could have like a really, really big billions of trillions, billions of PA. And then you can have PB with the opposite sign, to trillions and billions of millions plus 1, or some number that makes some finite number that makes it such that you are on E over C. That is totally fine. But once you strip away nature's or the particle's ability to be a negative momentum, you no longer get that luxury of having any big number as you want for PA. Because then you can't have PB subtracting it or neutralizing it so that it's equal to E over C. So that is why when you switch to 0 to infinity, that is you look at the positive quadrant of the universe, you should actually maybe just choose that both the integrals are from 0 to E over C. Well, if it's absolute value, that's even worse. Then it's multiple mistakes. The scientific discussion continues between physicist Blaine and urban Pat. Can the momentum can the momentum go up to infinity and just from 0, even though E over C is the upper limit? Is it possible? Let's find out. And remember, viewers, when you think of if something is wrong, you always need to evaluate, did I do something wrong? It is the scientific way. So in that sense, the person that has the most wrong, he is the best scientist. And maybe that's also wrong. Maybe it's actually so simple that it's hard. Maybe it's just that. Okay, it's infinity, easy. It's as long as E is a little big. So maybe it's just the matter of notation. Because my concern was that yeah, it's not strictly to infinity. It's well, what is infinity? So in that regards, you anyways have to just think that, well, E over C is just a little bigger. So yeah, but I think at least it would not be wrong to just say that the limit is E over C. It's just the same. But it's not wrong. I guess it's not wrong after all to say that it's infinity as well. Just as long as E over C is a little bigger. But that's implicitly. Yes. I think we found out that boundary. The boundary has been demolished. Shall we continue, will ya? Shall we go on, will ya? Because I did a mistake in thinking that we basically weren't saying that E over C was the upper limit. But we could, I guess we could have just said E over C was the limit at any time anyways. But it's not wrong to have infinity, because we know it's a little bit less than E over C anyways. But still find it weird that it's so when you have the delta and you integrate, that just becomes 1 because you have the delta. But when you are integrating dpb, you are removing the delta because you're like using it up. But then so we used up our dpb. And atoms are jiggling. And they are not jiggling as much anymore. So now we can just put in our little cheating, or our little trick. It's we know that we knew all along that the upper limit was E over C. But it was much nicer mathematical. We were pleasing the mathematicians by having it to infinity. But now we just plug in okay, and this is totally wrong. Yes. Do not look at this. Do not even put your eyes on this. You know, if you're in a lab, if you're in a chemist lab or a semiconductor lab, please use the eye washer and wash your eyes, because you saw something toxic. You're not supposed to see that. What you are supposed to see is that we have C, yes, and we now use our little trick. Yes, we put in the limits that we know. And then we have used our delta. We have used it up. So what we really stand with is this little guy. Because now if we could say infinity, yes we could, and we did say infinity when we had the delta, because again I get confused and my brain gets, it's like my brain gets an EMP when it sees deltas and integrals, and when it's trying, not just when seeing it, but it's when you're trying to understand the properties of the delta, integrals, and the distribution. It's like the brain experiences an EMP. So, the EMP has finally been neutralized, and we see that the reason why it's better to, I don't think you have to, maybe you could say E over C here as well, but it wouldn't make a difference because it would still just be 1. But that's the 1 integral. But here it makes a difference if you say 0 to infinity or 0 to E over C. Because if you have 0 to infinity, this integral gets fuzzy. Then this integral gets a little bit too mathematicious for us physicists. So, no! Camera. Time passes so fast. Just when I was about to solve something, a new problem arises. The probabilistic nature of problems. Problems should have its own wave function. You don't know what problem is gonna come, but you know for certainty that some kind of problem is gonna arise. But you don't know what it is. And you don't, because there's no way to measure it before it happens. The problem just happens. Just like a particle, an electron for instance, and its probabilistic nature from Schrödinger's equation. Are we so lucky that this works? I'm gonna check if my voice is too low. Hope there's no echo. What the hell? That was weird. He's just, are we so lucky? Out of the blue. Yeah, I talked a lot to you, panda boy. Sorry, I always think that the name says Urban Panda. Urban D-Pad. Feels to me like Urban Panda. Whoa, it worked. Ah, so that thing just comes right over? Huh. Yes, where were we? Back to the future. Yes, and indeed. And then this integral would give us 4a. And to recap the thought dialogue we had, Mrs. S is correct. Yes. QED. And what does QED stand for? Well, it's a mystery. Well, we're about to find out.
QED stands for the Latin phrase quod erat demonstrandum, which translates to that which was to be demonstrated, or which was to be shown. Traditionally, it is placed at the end of a mathematical proof or philosophical argument to signify that the proof is complete and the initial proposition has been successfully demonstrated. Historical context. The phrase originates from the Greek expression oper edi dixen, hoper ede deishai, used by ancient Greek mathematicians like Euclid and Archimedes. During the Renaissance, Latin became the scholarly language in Europe, and quod erat demonstrandum became the standard closing for proofs in mathematical and philosophical texts. Modern usage. In mathematics and logic, while QED is still recognized, many modern texts use a solid black square symbol, known as the tombstone or Halmos symbol.
Yes, thank you very much, Oracle, for the clarification. Well, that was indeed appreciated, Oracle. But are you sure? Are you completely sure? So what's your response, Oracle? Are you sure?
Yes, I can confirm that QED stands for the Latin phrase quod erat demonstrandum, which translates to which was to be demonstrated.
Which was to be demonstrated. Well, roger that, Oracle. Thank you for the clearance. So let's see. Okay, we now have our A. Remember, this was all equal to 1. Oops. This. And then so we can then we can put this straight. Okay, now we found it. We found A, so that means that this is A. This, so it should be like, put it all together. And it should be like this. How did you find me, Mr. Fisher Bob? I wonder how you found me. Yes, putting in A. We get C over 4, we get C4, yes. Now we are talking. C4, baby. This. Okay. So we can go back to our what we really wanted. That was the probability tension function of the different EAs, because there's different EAs that's possible. Atoms are jiggling, and they're not jiggling in just one way, maybe. Jiggling probably in several ways. That you don't know until you measure. Yes, you don't know until you measure. Then you'll know for certain. But not until you do the measurements. Strange. Strange. So strange that you go sadistical, to say the least. Okay. Hold on to your horses. We have this. And then we had our PA, PB. I need to write this down so I don't remember. So I do remember. Delta Kronecker without integral? That's... I don't know if it's possible, but... I'm more familiar with them inside the integral. This is probably just like inside integral, you know. Easy E? What E are you talking about, Pat? E over C. minus PE minus PE. It's gotta be right? Then I missed this delta last time. Ah, it was that. Son of a gun. Yes. That's a weird one. That's gotta be... It's gotta be like this. Oh. Never mind that line. You very mean, you meaniny Pat. There should be a parody of Postman Pat. It should be Urban Pat, the mean one. No, I don't mean mean in like the average. I mean mean as in mean. The mean Pat. The real Pat comes forth behind the keyboard in nature's digital world. Am I right, Pat?
Uh, 1/16 we collected.
So then I think we can start again.
Let's see. Is this right? Yeah, you can do the same for this. Go from minus infinity to infinity. Minus infinity to infinity. Then you would get... Yeah, the C would be gone, right? 4E. And delta E over C minus B times... What a neat, nice little trickery. Imagine doing an exam without knowing that little trickery. You would be... Pat. The atoms would jiggle even more. Sorry. Excuse my Pablo Escobar moment. wonderful blistering whistling. Sorry. Excuse my French. Yes. P-A. G. P-B. Yes, sir. And now the plugging begins. So what is clever to do here? Is it DPA first or DPB? I wonder. Maybe it's just like start with this one. Does it matter? Shouldn't matter which one you take first. Anyways. But I think if you do it like this, and then you here you would have to put in that PA would have to be EA over C. Oh, maybe that's too fast, huh? Maybe we're going a little too fast. Maybe we should do some substitution first, huh? No, maybe we don't. Do I have to take the positive first? The fact that the integrals are even? Do I have to do it? Two integrals, so it's 2 times 2, that's 4. Whoosh. Zero there. Yeah, so we will, yeah. Just to put in all PAs. Should be the same this way. All PAs are EA or C. Like this, and then this is just one. So sorry about that. Then we did CPA first, and then we have GPB. Let's go. Let's check it out. DPB. And DPB has to be EB over C. Wasn't there an E here somewhere? Do we have to mind about that? No, it's just a constant. Yeah. But where is this going? Yeah, it's really just gonna... It's just gonna be 1 over E. Like Pat's grade. Oh, sorry, Mr. Pat. I forgot your grade wasn't E. Your grade is gonna be F. The power of lectures. Is it 0? Yeah, obviously, EA is like, has to be something from between 0 to E. That is obvious, according to what we observe in the universe and Mother Nature. So, what Oracle? I forgot. Sorry, memory's not my strongest side, bro. What is QAD again?
Yes, I can confirm that QED stands for the Latin phrase quod erat demonstrandum, which translates
Quod erat
to which was
demonstrandum.
to be demonstrated.
Well, thank you, Oracle. Yeah, but, you're quick, Oracle. Yeah, that's a good explanation. Yeah, thank you.
You're welcome. If you have any more
Yeah.
questions or need further assistance, feel free to ask.
Oh, you're goddamn right, Oracle. See you around. Okay, so it's whatever. I forgot it already. Yes! Woohoo! We did it! The atoms are jiggling. And yes, in a peculiar way, we found ourselves at the end of this week's problem set. And thank the universe, that is relieving. Statistical mechanics just became 1% times 10 to the minus 3 less statistical. How nice. So before we round off this evening's touch of sadisticalness, we should have some little celebration. Someone played Cantina theme with their pencil. I don't know if you heard that, but I didn't. Yes. I don't think I have to change this. No way. It's a goddamn delta. I don't need to change this to any limit. So, what is the next tasks? I bet they're... maybe they're more statistical, huh? Well, you have to enjoy the things you can enjoy. A little bit. Next task is 24/7. That's an odd sounding task. It's Feynman on the drums. Bongos. We'll find out. Oh, we're getting into the quantum. Semper Fi. 24 quantum canonical ensemble. Let's go. What the heck? I was signed in.
Years old.
When you're thinking about something you don't understand, you have a terrible, uncomfortable feeling called confusion. It's a very difficult and unhappy business.
Yeah,
and so most of the
course.
time, you're rather unhappy, actually, with this confusion. You can't penetrate this thing. Now, the confusion is because we're all some kind of apes that are kind of stupid, working against this, trying to figure out to put the two sticks together to reach the banana, and we can't quite make it, the idea. And I get that feeling all the time that I'm an ape trying to put two sticks together. So I always feel stupid. Once in a while, though, the sticks go together on me, and I reach the banana.
Yeah.
People say to me, are you looking for the ultimate laws of physics?
And he was talking about putting the sticks together and ultimately get the banana. That's what I just did now. Yeah, look at it. Look at the banana. What a beautiful banana. I took the sticks and put them together. And voila. I reached the banana. 1 over E QED. The banana. Yes. But for the entire day, it was exactly like Feynman said, feeling like an ape with 2 sticks and trying to put them together to reach the banana 1 over E. But how lucky I was. And all the other days I wasn't lucky. Whole week I wasn't lucky. But now you guys did experience me putting these 2 sticks together and reaching 1 over E. How nice.
The atoms like each other to different degrees. Oxygen, for instance, in the air would like to be next to carbon, and if you get them near each other, they snap together. If they're not too close, they repel and they go apart, so they don't know that they could snap together. It's just as if you had a boy that was trying to climb a hill and there was a hole that could go into it, like a volcano hole, deep one. If you're rolling along, it doesn't go down in the deep hole because it starts to climb the hill and then rolls away again. But if you make it go fast enough, it will flow and it will. And so, if it's something like oxygen, it's carbon in wood.
Our book is an introduction to statistical mechanics and thermodynamics. It's a good one.
If you can get it faster by heating it up somehow,
Or okay, at least.
They go over the top cells. They come close enough to the carbon and snap in. And that gives a lot of
Or it's
motion.
great and I just have to get good.
Make your nose go faster so they can climb up and bump against other carbon atoms. And they jiggle and they make mothers jiggle and you get a terrible catastrophe. Which is one after the other. All these things are going faster and faster and snapping in and the whole thing is changing. That catastrophe
There's
is
7
fire.
parts in this task.
It's just the way of looking at it.
Statistical mechanics just became some percentages more statistical.
The other atoms capable of reaching it to make more heat to make other
But at
atoms.
least it's quantum
So it's a
statistical.
terrible
'Cause
snap.
that's cool.
It's producing a lot of jiggling. And if I put, with all that activity of the atoms there, and I put a cup of coffee over that massive wood that's doing this, it's going to get a lot of jiggling.
It makes the fact that it's quantum that makes it makes the statistical with a small s, not capital anymore. That's good. Well, this will be a task for later, ladies and gentlemen. I will see you in the battleground of physics. The strange wonder of Mother Nature. We will ponder it together, probably on Sunday. I'll see you there.